we acknowledge that the Canadian Science Policy Conference is taking place on the unceded, unsurrendered territory of the Anishinaabe Algonquin Nation. Those present here reaches back to time immemorial. We respect our traditional hosts and thank them for allowing us to operate on this land. Right now, we are going to start our panel. I repeat, 620 number. Panel will be devoted to technologies for Canadian food security, selecting the tools to translate food policy into sustainable food production. Please don't forget to tweet about your favorite panels at the conference using L Science Policy and hashtag CSPC 2022. And please don't forget to evaluate, give us your evaluations using conference app, because your feedback is very important to us and will help us to improve the conference in the future. So thanks.
Good afternoon, everybody. Welcome to this panel on technologies for Canadian food security. I would also like to acknowledge that this panel is being sponsored by the National Research Council, and the National Research Council, coast to coast, is situated in the traditional lands of the First Nation, Inuit, and Métis people. And avant de commencer, j'aimerais reconnaître que les panélistes et moi, nous trouvons à divers endroits, et ici, dans l'endroit des Anishinaabe et Algonquin peuples. So let us, personally, I would like to acknowledge this and to reflect on the reconciliation that we all need to continue to embrace as we understand more the rich traditions of the Indigenous peoples, as well as their generosity in allowing all of us to call this land our home. So, bienvenue à tous. C'est ma plaisir de vous bienvenue de cette conférence. Good afternoon, and my name is Lakshmi Krishnan. I am the Vice President for Life Sciences at the National Research Council. And today, over the next hour and 20 minutes, we hope to have a very interactive discussion on a very key topic on the Canadian food security, and focusing on selecting the tools to translate food policy into sustainable food production. I lead within the NRC the Life Sciences Division, and within our Life Sciences Division is the Aquatic and Crop Resources Development Research Center, ACRD, Surf and Turf for short, if you want a simpler name to remember that. And ACRD's main area is agriculture, including plant-based proteins, climate-resilient crops, and alternative production systems. And today with me, I do have a few of my colleagues here. So as you start to pose some very difficult questions, my colleagues may also jump in to help me, or the panelists answer those questions. So I also want to indicate that we will not be using the virtual app platform. We found that to be quite challenging in some of the panels yesterday. So to make it easy, we are, I think, a small enough crowd, and I'm very happy to have you all here. And so we will ask you to come over and ask questions towards the end of the panel. So I'll start by saying that we chose this topic because achieving equitable food security for all Canadians is of great importance, and there are many environmental stressors on our food system, and so new methods of production will be needed in the future for a consistent and reliable source of nutrition food. And this is, I think, very clear for us as in Canada. We are a northern climate. We are facing changes in our climate, as well as we are a resource-based economy. And this is, I think, very evident that we need to think forward for sustainable food production. Alternative plant production platforms offer the potential for year-round access to fresh fruits, vegetables, and nutritionally dense crops. Since there are many options in development, today's discussion, however, will focus on indoor farming under electric lighting. This platform appears to have the greatest potential to achieve year-round food production in both an economic as well as environmentally sustainable way. This discussion is going to be divided into two sections. The first will be a panel discussion, questions that I'm going to pose to our panelists. And in the second half, we were going to invite questions from our audience that our panelists will be able to respond to as well. For today's discussion, we have assembled a panel with very versatile experiences and expertise from the food industry, academia, and area of controlled environmental agriculture and under electric lighting. We will be starting with I will be starting by asking each of our panelists to approximately take 5 minutes to introduce themselves and address some important questions initially, and then I'll have some specific questions to the panelists. I want to start by saying that we do have one panelist who's actually joining us virtually. I don't see her video, but Nadia Sabeh is on, Dr. Nadia Sabeh is on virtually. It's actually unfortunate she was not able to make it here yesterday, given that we went from autumn to winter in a day and the flights just couldn't get here. So unfortunately, she's joining us virtually from California. So Dr. Nadia Sabeh is the president and founder of Dr. Greenhouse Inc. She received a PhD in agriculture engineering from the University of Arizona, is a mechanical engineer, and is licensed in both California and Ohio. Dr. Sabeh has designed specialized high-performance HVAC systems for plant-focused facilities across North America, Europe, Middle East, and Asia, including Northern Canada and Sweden. So you can see that she comes with a lot of experience that will be very pertinent to our discussion today. So what I'm going to start with is to ask Nadia to talk on the challenges associated with using indoor farming under electrical lighting for year-round production in Canada from the perspectives of unit economic. And so if she could take 5 minutes to introduce this subject and provide us her insight. So over to you, Nadia. I think we have some technology challenges there. Is she able to hear us? Okay, so maybe while we are trying to connect to the technology and get Dr. Sabeh online, I'm going to ask our second panelist, Dr. Crinman, to speak on the same topic. And so I would like to introduce Dr. Crinman. He's a director of R&D at Grocer right here in Ottawa. Crin received his PhD in agriculture science from the University of Queensland. Crin is passionate about improving food security and sustainability in Canada by advancing the technology and research of hydroponically grown plants. So Crin, if you would take about 5 minutes to introduce this topic around challenges associated with using indoor farming under electrical lighting for year-round production in Canada. Over to you, Crin. You may want to use the mic because I don't know whether your voice will carry to the end.
I'll just scream. We just gotta push on it?
Does he have to push the mic? No, just hold it. That's it.
Okay, awesome. Thank you, everybody. Thank you, Lakshmi. I'm excited to be here. Just let me know if anyone in the back can't hear me. Good. So just to sort of start the topic off, from Grocer's perspective, I would say some of the bigger challenges that we've seen with, implementing this tech and, in completely indoor farming under electric lighting. First, I'd say, well, it's a bit of an ecosystem. So I think it's got like your technological component, your economic, and your behavioral. I think probably Nadia will speak a little bit more about the technology. So economically, I think for us, we've always said that we got to work on what's economically proven or viable right now. So working on leafy greens, things like that, they make sense from a unit economics perspective. So a third of the cost would be your labor, a third would be your materials, for instance, and then another remaining third would be your profit. So that only works right now on a subset of crops. And I think that's sort of the challenge that we're seeing. being able to expand beyond the ones that are economically viable that work today is a lot more risky. So, if you look at it, getting into crops, let's say berries. I know a lot of people are probably aware of the Homegrown Innovation Challenge, doing berry production indoors. That's a lot more risky. Again, with the whole bottom-up approach, I would say, in terms of trying to secure financing through competition-based grants, makes it very challenging to have the financing in place to work on crops like berries that don't really have the unit economics in place yet. They're not proven. So we think that's currently a challenge that, you can only work on a subset of crops. I mean, it makes a lot of sense to do that, but taking on that risk into the space where you know that it doesn't work very well and you're competing for grants and trying to mitigate the risk and such, I think is one of the challenges that we've identified at Grocer for sure, from an economics perspective. And from a behavioral perspective, I would say that there isn't exactly an appetite for, across the board for a Canadian consumer. Not everybody can afford, more expensive produce and fruits that are generated locally. I think it's pretty safe to say that we don't have as robust of a domestic supply chain in Canada. Half of our produce is leaving the country, and then 80% is being, up to 80% is being brought back in the form of produce and fruits. So, in the end, paying more money for that produce is a challenge. So I think it'll be very important to sort of put our attention toward developing more robust domestic supply chains, because right now the gap is actually closing, I should say, between, fresh produce that's produced locally rather than the food that's coming into the country. That gap is closing for sure, with respect to higher food production prices and consumers having a better understanding of, or more transparency around, the true cost of bringing in food into Canada. I think that price gap between the two are closing, but at this current time, there still remains that challenge that, largely speaking, Canadian consumers are going to, they're not going to have a great appetite for paying more money for the same thing that's being produced in Canada. And I think a big challenge around that is that like I said before, we need to improve our domestic supply chain and put more effort into that. Yeah.
Remarks, and so I'm going to pose the same question to our third panelist, Dr. Mark Lefsworth. So Dr. Mark Lefsworth is an associate professor at Megan University, leads the biomass production laboratory. He grew up on a farm and working on the oil fields of Alberta, Canada, combined with his BSc and MSc in agriculture and bioresource engineering and a PhD in plant physiology. I think it gives him a very strong background in the fields of agriculture, biology, and engineering to add to his comments on the topic of growing indoor crops and other electrical lighting, and also the perspectives of unit economics.
Great. Thank you for the invite on this. So my name is Mark Lefsworth. As was said before, I'm a professor at McGill University. I'm going to get a bit of context to this. So I come from Alberta originally, and so I have come from an agricultural farm there. I always say it's a reasonably small farm for Alberta standards, but it's about 3,000 acres, which I know for the East Coast is reasonably large. And so I have the perspective of what rural agriculture is like. But when I was a kid, I decided that I needed to start trying to figure out how to grow plants in space. I thought that was the cool place to be. So I actually worked for a company called Orbitech, which designed a bunch of the technology that's up on the International Space Station. So the two is the Veggie Plant Growth Unit. So I was one of the instigators of that, and then something called the APH. So the two systems that are flying in space. So I go from large-scale agricultural type systems, which is where my brother's farming currently, to these really small, basically shoebox-sized systems. The challenge is ultimately is that we have to be able to control the parameters that are occurring in the outdoor world and bring them into a shoebox. which means that we have to be able to control light, temperature, humidity, gas exchange, all these things that are usually just taken for granted. Due to climate change, people are now paying attention to at least the atmospheric gases, but I won't say they care about anything else on it. But if you're dealing with NASA, you have to care about the energy in, energy out, mass flow dynamics, and all these things. The difficulty that we have is that those are the two extremes of the world, at least from my perspective. I don't know if you can get much more extreme than those two. But then if you move up into northern regions or even more isolated communities or even urban cores like right here, we run into a lot of the same kind of parameters. So how do I control water in a place that is the middle of a desert? How do I control energy uses when I'm in the far north and we have to use diesel fuel to supply this? So these cost economics come down to each one of these parameters. In some cases, we've become fairly good at getting some of the solutions solved. So currently, we shifted from an HPS lighting technology, which is typical for a greenhouse, and we're going into LED lighting technology. Not quite double the efficiency, but it's close. And so the energy uses of these start improving, but I keep saying that we're not there yet. It's kind of like Moore's Law. At some point, we're going to get good enough that we can start producing food everywhere for everybody all the time. We're not there. And I don't think we'll ever be quite there, as I saw at the quantum physics one where they're using Star Trek as the analogy. In our world, they just go up to the replicator and then make food directly. I don't know if I want to eat that food at this point, but maybe in the future it might be good enough. But can I have a little garden system that I can set on my countertop and grow enough lettuce that I could feed myself or my family? Or do we want to go to a larger system like Grocer has, which can supply a small little sub-community type system, or do we want to go into larger? So the scale of these things are very much dependent on what your inputs are. So if I need to use fossil fuels to drive the electricity to drive my system, that's going to cost not just on the power uses, but also on your carbon footprint and all the other consequences. If you're across the border in Quebec, which I think is that direction, now we have hydroelectricity there, and we can say, well, we're really cheap. And we're good. But we have to do that for every one of the parameters. And I won't say we're there by any stretch. We don't have a good way of recycling CO2 at all. Our HVAC systems are horrible at least from a plant perspective. From a human, they're wonderful. We have a nice warm room inside of the space. And Nadia hopefully is going to rant about the HVAC system there. See, she's good at it too. So I listen to her most on these things. So we can see how the dynamics are building. I've been at this for about 20 some years. We've improved a lot, and we're going to get to the point where people care about it. I'm hoping you guys care, and since you're here, that's probably a good sign. But we also need the people who want to consume it to care. So this is touching on the social aspect. So the communities that we're going into, there has to be a dynamics where people are interested in this. Telling everyone they have to eat kale because it's nutritious, which it is, by the way, so you should all have eaten the kale salad today. But most people don't like the taste of kale. I can't convince my kids to eat it, even though I did a lot of research on it. And so how do we get this social dynamics? Going into some rural communities, they're just never going to like some of these products. It doesn't matter where you are, urban centers or far north. And so there's a lot of different spaces that we have to work on. So we have to try to build up this ecosystem of expertise, knowledge base, and research simultaneously.
Thank you, Mark. I think that was very rich kind of different perspective you brought in here in terms of the social dynamics. And I'm very glad to see that Dr. Nadia Savvy is online, and you are larger than life for us, so thank you. And I'm not sure that you can see the audience, but we're very eager to hear you. And we was just telling them we are very happy that you can join us virtually, but really sorry that your flight got canceled yesterday, and we just summoned winter too early, and that you could not make it here. Another reason maybe why we need these food technologies, right? This type of unpredicted environmental change is probably going to be the norm in the future. So the introductory question I was posing my panelists, Dr. Sabe, is just to take maybe 5 minutes to provide your perspective on the challenges associated with indoor farming and electrical lighting and year-round production, and from a perspective of units economies. So over to you.
Yes, thank you so much, everybody, for having me. I'm sorry I can't be there in person. I was really looking forward to this conference, but winter came early. I hear there are feet of snow on the ground where you all are, so that's very exciting. Well, I'm going to give you some perspective like Mark did, which is that I'm in California. which is the salad bowl of the country, maybe of North America, where we produce a lot of the vegetables, the lettuces, the tomatoes that you all in Canada receive and probably have a shelf life of about 2 days if you're lucky, if it gets there in good shape. In California, it seems like a weird place for someone like me who focuses on indoor agriculture and greenhouse production to have this focus because of how much agriculture drives the economy here, field agriculture. But we are dealing with a lot of challenges, as many of you know. We don't have a lot of water. We are dealing with the longest drought in thousands of years, or 700 years, I think, is the longest drought that we've had. We also have been having a lot of fires and smoke that is affecting the quality of the produce that is growing here. And so, indoor agriculture helps to potentially solve some of those problems by closing the loop on the systems that we need to grow food. So for instance, water, instead of, field sprinklers and flood irrigation, by growing indoors, we can actually recirculate the water that we're using to grow those plants, not only by circulating the water through hydroponics and aeroponics systems, where we're delivering water and nutrients directly to the roots, but also by collecting the condensate that we're removing from the air through the HVAC systems through dehumidification. So we can theoretically close the loop on water and reduce how much water we need for agricultural production by anywhere from 70 to 95%. Basically, whatever water just the plant holds on to is what could actually leave the building. And in terms of air quality, in terms of smoke and fire and some of the other environmental challenges that we're having here, by having enclosed growing systems, we are less susceptible to what's happening outside, whether that is climate change, whether that's fire and smoke, whether that's pesticides drifting in, right? Maybe we don't want to have chemicals drifting in from nearby farms. We can close the building and recirculate the air so that we are completely closed off from those challenges outside the four walls and roof. So big opportunities there. The other thing is that, at least in California, the average age of farmers is greater than 65 years old. So our workforce is aging, and that is a trend we're seeing all over the world. And what I think is really exciting about indoor agriculture is that young people are interested. They're interested in the technology. They're becoming more interested in gardening, in understanding where their food is coming from. They want to have a relationship with the farmer, with the food that they're consuming. And by having indoor agriculture in local and regional communities, these young people and populations at large will have greater connectivity to the people that are growing that food and serving that food to them. I think in northern climates, I live obviously in a very good climate for growing food crops. But as we move north, the challenges get a lot harder because you don't have consistent quantities of sunlight year round. And so you have to supplement with electric lighting, whether you're in a contained indoor farm or even a greenhouse, right? The very northern communities might have 24 hours or close to 24 hours of darkness in the winter. And so we have to provide electric lighting. One of the potential benefits of being in a northern climate is that it is cold and dry. And one of the biggest energy challenges that we have in indoor farming is HVAC, is that heating, ventilation, and air conditioning and dehumidification that we need to manage the environment to the temperature and the humidity that plants like. Mark mentioned lighting, but I specialize in this climate management, design, and control. And when we have access to that cold, dry air, we could actually potentially use that now to dehumidify and manage the climate inside rather than using energy-intensive HVAC systems. I'll leave it there.
Thank you, Dr. Sabe. I think that's the three panelists here have opened up a lot of very interesting challenges that we face when we think about indoor farming. So the closed systems and how we build them, the scale at which we build them, the labor force, and what Dr. Sabe introduced in terms of, the uptake of technology and who would be willing to take up technology, the profitability that Krin mentioned, and of course the social dynamics of, are we ready to accept this change in farming? So I think there's a lot of, food for thought there. And so my second question to our panelists, given the challenges mentioned, what policies or systems are required to help finance and implement these technologies across Canada? So, Krin, maybe I can get you to start on us and give us some perspective on how do we advance and implement the technologies across Canada, and what policies can support these?
Yeah, awesome. Thank you. I think from a policies or programs perspective in terms of implementing technology, if insights from Grocer. I'm sorry, I didn't give you guys a bit of a background about Grocer. In case you guys don't know about them, I'll quickly rip that off. We're a socially minded company that empowers communities across Canada to grow nutritious food hyper locally and year round. So Grocer is a fully indoor CEA, or controlled environment agriculture unit. And so we have a lot of perspectives from, the 55 farms that we have across Canada. And the biggest thing that always comes back for policy or programs or what needs to be in place to implement the technology successfully, it comes down to financing. So the number one driving force is the financing behind that. And I can give you two perspectives of what that impacts and why we need more of that for those kinds of processes. So it's the research and development arm, as well as the access to capital for infrastructure. There's a lot of people that want to work on food initiatives, but they can't secure the financing to do that. So from the perspective of from research and development, I think increasing the number of government support programs is going to be necessary to help keep driving the research and development on the crop research. If that could be in the form of financing or subsidies, whatever the case might be. Again, that could be the top-down approach the government would take in sort of directing these programs for research. But I think there are a lot of initiatives within R&D and our perspectives that the financing could be put toward working on crops that we're already really good at, but can improve further. So that would be your lettuce and kale, arugula, spinach, stuff like that. And then the financing to help mitigate the risk into getting into crops that we don't know very well, or there still needs to be a lot of research done for those. The reason I mentioned that I think programs are going to help support this part is right now we see a very heavy reliance on private sector funding to do research and development. So that's your foundations. And I sort of alluded to this earlier, where it's the Weston Foundation right now that's supporting indoor berry production in Canada. It's a $30 million plus grant, but only a handful of winners are going to walk away with that money. But that money is going to be put toward critical research that we need in the country to sort of expand our crops that we can grow indoors. So not actually having as many programs in place, and it's not to say that we don't, especially with the ADM and ISAD that we just saw a moment ago in the main conference room. But I still think that we need to increase the number of programs to support that, because right now it's a lot of competition-based funding, and only a handful of winners are walking away with that. So there's probably a lot more research that we could be doing, and I think the programs can support that. The second perspective that we have that I can offer is financing for infrastructure. Currently, Grocer itself has a long list of Indigenous communities that would like to work on, various food initiatives that are of great importance, but they can't secure the capital or the financing to do that easily. So there are a lot of individuals and communities, entrepreneurs, farmers, and the like that want to enter this space, but the rate limiting step is the financing there. And again, what we've seen is a lot of the financing is coming right now from banking institutions. So there isn't as many programs from the government. Let's say something like, I don't know, we could use something like a guaranteed loan or guaranteed financing that could supplement the financing to get infrastructure aside from going the route of the banking institutions. So even though there are specialized agricultural funds that come from banks, this is a pretty new industry, and they're pretty risk adverse. So their risk tolerance is quite low. It's a new industry. And in the end, what that means and translates into is we don't have programs to accelerate the adoption of this technology. It's harder to implement, and it leaves communities, entrepreneurs, farmers with little or no accessibility to financing, and that really limits the space quite a lot. I think there could be, I don't have a perfect answer on what the program should be exactly, but I think something like guaranteed loans or guaranteed financing from the government will play a huge part in the programs toward R&D and then securing infrastructure costs.
So that I think speaks to what our ADM Nippon was saying about having the vision in the long term, perhaps, because these are going to be high risk endeavors in the long term. Mark, would you like to add anything else from your perspective as to any specific policy instruments that could really stimulate this area of R&D and moving towards this direction?
Yeah, thank you. So I wrote down a whole long list here. I'm not going to talk about all of them, obviously. Don't think I have quite enough time for that. Government, so I'll do a bit of historical just because I want to try to bring that into this. So government used to be quite a large supporter of agriculture per se. We used to have quite a large plant breeding operation. This is from field perspective, obviously. And over the years, we also had ag extension officers in almost all provinces. And over time, these things have slowly decreased. I blame all of us for it because people have cheap food and they don't care, is the short answer of this. Once food becomes harder to get, then people start to care about it. I make a bit of a joke, and it's not a good joke, but it's still the idea that the best thing that happened to agriculture is we've had a drought and we have a war in Ukraine. So people have a chance of starving, which is sad and it's depressing. And those of us who work in this industry have been trying to get people, policymakers, to be aware of these issues for the last 30 some years. We've been putting money into breeding of Arabidopsis and genetic work on Arabidopsis at a level that is shocking. And I worked on it, so I know how much money goes into Arabidopsis. Nobody cares about Arabidopsis. Anybody who does, you don't eat it. You don't do anything with it. So all these breeders that used to breed for the wheats, the barleys, the fruits are no longer working on that. They're working on genetics. We need to have breeders that are focused on some of these crops. We're starting to. The United States is actually hiring people specifically for that. Canada has none of this. But we're one of the world leaders in agriculture and in controlled environment agriculture. Grocer being one of the many players in this world of this. So we have almost none of this happening here. And I just find that slightly depressing. My students that I graduate from the university go down to the United States because that's where the jobs are. We don't have the initiative to try to drive this, even though it's one of our largest parts of our economy is agriculture, and food security is a huge component of that. And so we need to have initiatives to try to push into these directions. So plant breeding, a huge one. Transportation and moving things around at some level, or storing them. If you go to remote locations, they either barge them in or they fly them in. And in some cases, we get to do ice roads, which make for really cool movies, but are not a good way to haul around transport of food most of the time. So how do we try to use these locations and the assets that they have? We look at them as having nothing, but as Nadia pointed out, when it's minus 40 out, we don't have to really chill anything. There's no cooling costs involved. So that's a benefit. If you're down in her part of the world, down in Sacramento, they have huge cooling costs that have to be at play on this thing. So we're looking at it purely from a perspective of what do we have to contribute instead of what do we have. And so we have to be able to take those components into it. The last thing I'm going to talk about, which is the huge one out of this, is that we have to have some leadership or education component for this. So there's a few places in North America that are focused on controlled environment agriculture. There's two in Canada for all intents and purposes. So that's Guelph and McGill are the two that are probably graduating the most people. There is a few other smaller single researchers that are doing this. But until we get people at a threshold knowledge base that know how to grow plants and how to operate these things, it's going to be really hard to try to build these expertise up. If we go into remote locations, most of them don't know what kale is. I don't think they care. But we have to have somebody who's an advocate that understands what these things are and can build up this expertise. So we need to start building centers of excellence, building up these training mechanisms, and then allow the flow through. I like mechanical engineers. I started out there. They don't know how to grow a plant worth a damn. Zero understanding of it. And I can pick on every other group out there. So we need to have a knowledge base. It takes 3 years to become good at growing plants. Anybody who has a plant in your house, you're probably growing a succulent because you don't remember to water it most of the time, right? So this is a given. So we have to train these people up to understand these things. And so it takes a lot of education. You don't need always a PhD, but even a weekend short course improves you drastically. I love hanging out in the hydroponic stores. And geeky of me, but they're also the cannabis people that sleep with their plants. And so they have a passion about it. I won't say they're always right, but at least they have a knowledge base that they can feed to me. I don't want to smoke their stuff, but that's fine. They have this other information. So you have to be able to communicate this information between the groups. So education is huge.
Great points, Mark. So I can see that there's a lot to discuss. And I really like what you said in terms of the environment and where we are could actually change what type of policy we need, because what might work for Canadians, maybe it's different. So I don't know, Nadia, if you wanted to add from your side, what policies are you looking for south of the border? And are there similarities in policies that all countries should embrace?
Yeah, Mark brought up some really good points about education and ag extension that I just kind of wanted to expand on. You know, here in the U.S., we have the USDA, the U.S. Department of Agriculture, that does focus a lot on research, on specialty crops, on urban agriculture. I know we're not necessarily talking about urban ag right now, but they expand their reach as there is greater interest, as there are movements. They start to move money in those directions to see, right, to help determine, one, to do the research, is this a viable, feasible, new system of agriculture? And if it is, okay, then they move money into the research and technology development to then prop that new form of agriculture up. We are really lucky that President Lincoln created the land grant universities when he was a president 170 years ago, 160 years ago. And what that means is that every single state in the U.S. has a school, has a university that is focused on agriculture. In fact, it's called the Application of Mechanical Systems to Agriculture. And Mark, I know when you poked fun at mechanical engineers, I was excluded from that poke. But we recognize 160 years ago the importance of engineering applied to agriculture, and University of California, Davis, which is really close by here in Sacramento, is our land grant institution here. And also to speak, to Mark's comment about ag extension versus, the hydro stores, that, and I know we're not talking about cannabis here, but kind of a parallel is that, there's not a lot of research, and there is definitely no ag extension around cannabis, at least not that's hemp now here in the US. And so these hydro stores have basically become these default ag extension offices where people can go and ask questions. And kind of like Mark said, I don't know that I would trust them and what their advice is, but they do sleep with their plants. They love their plants. They're gardeners. And they probably do understand it better than, the university professors down the road. And so similarly, when we're talking about food production in Canada, is having that university relationship and partnership to respond to growers' needs. Right, that's what ag extension is about. It is really about doing research, doing education and training with growers, with farmers who have real problems, and they bring their challenges, they bring their problems, their issues to these land grant universities and ask for help. And within that, there are trade associations around that where, here in California, I'll just say the Almond Board is a really big trade organization here in California, and they all get together. They pool their money together. They decide together, here are the challenges that we're facing. And then they go to UC Davis and say, here's some millions of dollars. We want you to address this. And the university then does, right? Through all of their programs, through plant science, through ag engineering, mechanical engineering, et cetera, and creates these collaborative research objectives to address these issues together. And so I could really see something like that happening here with indoor farming in Canada is, if there is a trade association or an organization that came together and said, hey, Guelph, hey, McGill, hey, these other schools maybe now that have sort of, a land grant type of I guess, grant, please help us address these problems, because the issues that have been identified by both Corinne and Mark are real. One of the things that I wanted to add to what Corinne was talking about with financing is that for a lot of indoor growers, whether they're down here in the States or up there in Canada, they often can find the financing to start a company, to start an indoor farm, but it's a lot harder for them, especially early when they're, trying to figure out how to operate the farm efficiently and effectively. They may actually lose money before, and so it might take a few years to be in the black and have a positive net revenue. That having some support from the government to continue those operations until they are in the black, I think would be really helpful. So I know that that's a big challenge in general with this industry. Also, I just want to talk, workforce development. Mark mentioned education through the universities, and short courses and workshops and hands-on training. There's the Master Gardener program that we have at all of the land grant universities here in the States. I don't know if you have something similar to that in Canada, but that is hands-on training where people learn how to manage their garden, manage plants, and then they get a certificate at the end that they know what they're doing. They know how to water their plants. They know how to, fertilize and manage the soil for their crops. And so having those types of training opportunities for indoor farmers, I think would go a long way in both the retention of these farmers who are getting into it, as well as just, the general day-to-day operations and feeling like they're accomplishing something, being efficient about it, and producing a healthy and safe product at the end.
Thank you, Nadia. I think I really like what you said there, that there's still hope for some of us, like myself, that can't even keep a succulent growing indoors at home. And if my husband's gone for a week, I will definitely kill the plants. So I really like this training that will make me a gardener. So I can see the value in that. So just shifting slightly gears and thinking about, the perspective of Canada and northern agriculture, given the harsh climates. And we heard our panelists talk here about some of the advantages in being in a northern climate, is that perhaps we don't need to freeze. Maybe our environmental costs are slightly different, but then there are other challenges given that we don't have growing cycle all through the year. So to inform this question, actually, NRC held a pre-panel discussion on October 31st, which was very specific to northern agriculture. It was a separate discussion where we brought in a number of different presenters to talk to us about their experience. And in this way, we could actually gather, even prior to this session, some of the ideas that were underway in terms of indoor agriculture projects in northern communities, and discuss the considerations required to implementing potential platform and technologies. And our panelists were there at the discussion that day. And the discussion highlighted the importance and collaboration in the development of indoor farming platforms to incorporate indigenous cultural practices and local preferences. Dr. Nadia just spoke about it's important to collaborate because you need to understand what the farmer needs before you actually develop the technology. And then you need the experts to come around the table to develop the technology. But when you go to northern communities, there's another angle that it has to be something that speaks to their cultural practices and local preferences. So for example, the current technology platforms are often very compact and limited in space. And this is not really my field, but while listening to the people there, I was actually quite, it was a revelation for me when they said that in many of these communities, when they put these indoor growing kind of farm units, they are restricted and limited in space, and it's not culturally a place people want to be at, because for them, gardening is a community endeavor. You want many people to be around in your garden, not just two people inside a container and a plant in a hydroponic. So you really need to kind of think about these aspects when you can also trying to bring these technologies to northern communities. Another critical component to address is the codependency created with these high technology units, right? The incorporation of these units requires access to several consistent, reliable inputs, such as internet. We talked about transportation. You need a fresh water source and energy. And in many northern communities that are struggling even to have water in their homes, these inputs are not consistently available. So a technology and an operations that might be quite suited for an urban environment like, say, in Ottawa or California may not really be suited for in northern indigenous communities. So addressing this kind of aspect, what I'd like to do now is to turn to our panelists and get their further insights on this topic. So based on our discussion and your further thoughts on this topic, what are some of the specific considerations that you think are required for northern communities with limited infrastructure to adopt these types of solutions for year-round production? So I'm going to ask Mark to start us on that topic and give some of his ideas on that.
Okay, thank you. So if we're going to start talking about First Nation communities, we have to be respectful of what their views are in their land. It can't be a southern solution for a northern problem. That's the worst thing that anybody could try to do. They get grumpy, they just walk away. So it has to be agnostic. So we have to provide possible solutions, and then they have, as a group or individuals, have to be willing to use those. It becomes complicated because you need to have somebody who's a local leader, somebody who wants to take it on as a mentorship, and usually has to be trained in some of this. And then they have to try to convince the rest of their community. So usually it doesn't have to always be an elder. Elders are always more beneficial in some ways than a young whippersnapper, to be perfectly honest. But as long as somebody in the community sees it as a value, then you can actually start to build for these parts. There is also the problem that, if I keep going back to kale, because it's an easy one, nobody wants to eat it. The International Space Station, they still didn't want to eat it. So it doesn't matter where it is and what the group is. So finding plants that are either the same as the local community or finding plants that are close enough that they're accepting of these is one of the large challenges. Everybody goes strawberries. Everybody knows strawberries. Almost everybody likes strawberries. Probably some that don't, but we'll ignore those people for this argument. And so as a whole, you can buy those or grow them or harvest them wild almost every place. So do we have to grow strawberries? Well, maybe. They're reasonably easy to grow, but we can also grow other berries. So one of the things we've been trying to do is grow things like cloudberries. It's not one you ever find in the grocery store. They grow reasonably well, but they have their own ticks like all other plants do. And so how do we find these systems? And it kind of harps back to that whole breeding program that I talked about before, is that we need to be aware of what plant systems are that can be grown indoors. To be perfectly honest, I say I can grow anything. If you gave me enough money, I can grow palm trees indoors. Don't know why you'd want to do that, but we can do that. But we need to find plants that are of high value. One of the comments at that meeting was that there was a few plants that were growing that looked almost identical to a plant that is native to the area, and people couldn't get enough of it. And you're like, oh, that's awesome. I can grow you that. Let's keep doing that. So we have to have these partnerships with what the people want, have somebody on the ground who actually cares about it and is willing to take it on as a leadership. And then the last one is some of these communities are tiny. Like you might go to some of them, they're 20, 40, maybe 100 people in some cases. You're not going to have a large breadth of knowledge. So the equipment has to be, I describe it as idiot proof, which means that me under my worst conditions can still operate it with nothing. So taking a bit of string and duct tape should be able to pull it. So if you've ever watched Red Green Show, duct tape should be able to solve the problem and allow you to operate these things. If it's more complex than that, we got challenges. I know we need to have pumps. We need to have these other components. I can't build everything with duct tape, but you have to look at it from that perspective. How simple can it be and still operate? And as long as we can meet those conditions, then it will be nothing worse than going, well, we're going to let all our plants die because the pump we need is in Toronto. And guess what? That's probably going to be snowed in for the next 2 weeks. So all the plants die. So we need to have some mechanism of being able to bypass these things or having things stored so that we can operate these things along the way, which takes a lot of engineering, but it also takes the education and training components.
Thank you. Thank you, Mark. So maybe I'll ask Corinne to add to that in terms of your perspective, because I know Gross has been working with many Indigenous communities and trying to bring these technologies to their communities.
I fully 100% agree with like everything Mark said, which was, the buy-in from the community. We've seen that. That's above all else so important. Having someone run the farm, that's key. And just to expand a little bit on, reducing like the risk or the error rate, the making it idiot proof kind of thing. What we've noticed with working with communities, if it is a remote part of Canada, I think there's a bit of a design aspect that's important to consider. So there are different versions of like hydroponic technology. I'm sure everyone is aware of those. One of the most forgiving ones is a deep water culture. So some of the times that like when we think about what's the best way to, deploy a farm in a remote community, that's kind of the consideration we will make sometimes, which is the design and the technology approach. So a deep water culture, if anyone's not super familiar with that, it's just a lot of water. It's like a pond and the plants are sitting in it. The roots are sitting in it. And it's important to actually approach it that way because let's say the power does go out. I mean, we've seen and spoken about infrastructure concerns. That could be one of the most protective situations to have your plants in then. So all the power goes out. There's a lot of water. It's very good at retaining heat, and it can kind of keep the plant alive a lot longer. So it is more forgiving, and I totally agree with Mark on that. And just from like grocers like perspective, just like not trying to promote anything or anything specific, we just think it's really important to consider if you drop that technology into someone's lap and then you're sort of hands off is really not the way to go. We have a customer support team, we have an engineering team, and we have a research and development team. All of them work on the project with our partner over the longevity of the project. And I think that's just a really important consideration because you want to work with your partners and make sure that you're learning together. There's a knowledge transfer. It's not something you can just easily pick up and know all the kinks and it's just going to go perfectly. So I think that was an important thing to sort of convey to you guys, that after that relationship develops over time, having that knowledge transfer to a community or the people running the unit, they're going to become more self-reliant. They will develop a mastery in that area and have that expertise. So we've always thought that, that's just a critical thing, that you got to work with your partner or the community throughout the entire process if you were to deliver that equipment to them or that infrastructure.
Thank you, Corinne. So I'll just ask Nadia if you want to add anything in terms of Indigenous communities. Are there different considerations for Indigenous communities in Southern Indigenous communities versus Northern Indigenous communities? Some may be the similar challenges and some may be different. So do you want to add your perspective to that?
Yeah, a little bit. The first thought or the first question that came to my mind when we had that pre-panel discussion is, what do Northern Indigenous people normally eat, right? And the answer was that they primarily eat caribou, seal, and it may be fresh, raw, or frozen, and that their access to veggies is somewhat limited, and they may not be familiar with some of the vegetable crops that we would normally think of growing in an indoor farm or even in a greenhouse. And that, we need to look at what are they familiar with. And like Mark mentioned, there is a type of leafy green that they're familiar with that they would be super excited to be growing in their indoor farm. But also, what other vegetables might they enjoy that they have not had access to in the past? And maybe having tasting panels with them, right? Like, do you like spinach? Do you like kale? Maybe they do. Maybe this is a community that loves kale, and different sorts of vegetables that they might be able to grow. And the other thing that sort of dawns on me with that, fresh, raw, or frozen is that I don't know if any of you know this, but frozen meats actually was inspired by the founder of, I think, of a frozen food company. I can't think of what they're called right now, who was fishing in Canada, put his fish up in his cabin or whatever, and they all froze. And he was like, oh, well, darn. And then he actually let it thaw, and it still tasted just as if he had just caught it. And so, what that kind of thinks for me too is that they could be growing vegetables. Even, we think about, Mark mentioned, some of these communities might be 40 people large. Others might be 4,000. And then, we grow from there. And so it's like, well, how small is too small, right? Should we be thinking about these micro communities that might just have, tens of people, or should we be thinking more regionally and serving larger communities? But, when I think about this sort of idea of frozen, I think, well, if you overproduce in the summer, could you then freeze it or can it, right? These other ways that we can preserve food that may be more difficult to grow, or if there's a failure, right, of the equipment, you still have that food stored in another way. And because it is negative 40 degrees quite a bit up in the northern communities, there's lots of opportunities to freeze it without using any energy, right? Just having just a cellar basically type of building where you can store those foods and eat them as needed. The other thing that I wanted to communicate that Corinne was starting to bring up has to do with the type of technology that's used. And one of the big challenges of any indoor farm, whether they are located remotely or they're in a city, is that there are failures. There are equipment failures. Pumps break down, motors, fans break down. There can be power outages. And one of the things that some indoor growers like to have, even down here in the States where we have pretty mild climate most of the year, is having parts available on site. So having the ability to replace those failed parts without the assumption that pump is going to last forever. It might not even last an entire harvest cycle. We've had that problem ourselves here in our little office R&D farm. So making sure one, I had that these farmers, whether they're small or large, have replacement parts on site and know how to replace them. I think that's one of the biggest shocks that a lot of indoor farmers have, is that they're not just gardeners. They become plumbers and they become mechanical engineers, and they're fixing things a lot of times. And so when we talk about training, and we're talking about breeding and understanding how to grow plants in this master gardener system, but we also might need to give them a little bit of technical training as well, so that they feel comfortable when something breaks down to fix it.
Thank you. So I think what the common theme I'm hearing is that in any of these type of situations, when we're doing, community programs, it's really the pull for, and the need is to be driven by the community. So I think, engaging them early on becomes a very critical aspect of how we progress, including the types of plants we want to grow, the types of systems we want, and also anticipating what that environment may pose in terms of risks. So I'm just going to now move to the last question, and we'll ask my panelists to deliberate just for a few minutes on that, and then we will be opening up the podium for questions. So those of you who want some post questions, you can get prepared. So the last question, and I'm going to start with you, Nadia, and maybe if you can tell me, what role can the government play in establishing the ecosystem to help facilitate both scientific and technical advances? So if there was one or two things that you think the government should definitely do, what would that be?
Yeah, thank you. I would say one is to have have government-funded R&D programs and educational programs for any communities who are interested in this technology. The other thing that I would say is make it easy. Make it easy for these communities to adopt these technologies. If it is a community-driven initiative, there's going to be so much interest in applying indoor farming technologies. But sometimes that excitement and that enthusiasm gets squashed by the bureaucracy of paperwork, of documentation, of reporting, of, just having to fill out a lot of papers. And so finding ways to streamline that process and maintain that enthusiasm to do it. Maybe that means having somebody at the government who walks through that with them, either in person or say over the phone. And just streamlining the system so that they want to continue the process and don't feel sort of overburdened by red tape.
Thank you, Nadia. I think we all could do with less bureaucracy for sure, and that would be a great message. Make it simple. If you want us to access government programming, make it simple. Mark, is there one thing that you really would push the government to do in this sector?
Well, I actually have 4 here.
Okay,
So
we'll give you 4.
I'll take the 4. Nadia touched on the one. The research center and the university training are the big ones for this. I've been told, and hopefully this does happen, so very promising, where currently Northern food is subsidized. We transport most of it up from, I find it odd that we take things from Mexico, bring them to California, to bring them into Canada, fly them up to the far north. And so if we can do some kind of subsidy so that they can grow food locally at the food level, not just giving it to a company and say, okay, set up a greenhouse, but actually subsidize so that the food costs that are reaching the actual consumer in those locations. I have toured a bunch of the locations and seen it was the melon that was sitting for $45, kind of was a bit of a shock. Like, that's kind of crazy. So if there's a way to bring that down to $4, you'll get people to eat it. Maybe they don't know what it is, but I force my kids to eat a lot of foods they don't know what they are. So it's a way to try to learn some of these things. They don't like it all the time, but at least they have that. The last one is we have to figure out where all the holes are, and there's a lot. So I'm calling them bridges. In some cases, having an ability to store products in a local place. So if we need those extra pumps, or we need to have growing media, we need the nutrient solution, having systems or warehouses in location or someplace close to locations so that we don't have to fly them in. I know a lot of these northern communities, as I said, are barged in. They get that barge once a year. It's exciting when it arrives, but if it doesn't have what it is, then it has to be flown in, or it has to be ice road in if they have the ability to do that. So there's challenges on this. And so having the ability to bridge through some of these challenges, so the storage ability and not making somebody who's going to be building a container-based system also have to have all the storage ability to hold everything else. So if we can build those bridges, it will allow all these other things. And I like what Nadia said also, so making it simple. So yes.
So, Corinne, I know you already mentioned about R&D programming and infrastructure programming. Is there anything else that you think the government should be doing?
I would just mostly say that just sort of taking a more planned approach or direct approach in, sort of promoting partnerships. That's probably what I would say. Just with I think we've talked a little bit about the data siloing and, companies sort of competing against each other. And I think it makes a lot of sense if the role of the government could be, and I alluded to this before, but more of a top-down approach. And that could be in the form of partnerships. So, collaborations between industry and federal and academic, I think would be really important to sort of revamp our innovation ecosystem. And sort of touching on what both Mark and Nadia mentioned, I think there's like a skills component in training. So it can be very specific, but, just as this sort of market develops and how much demand there will be and how much money is going to be coming into it, putting that education forward and the specialized training for AI, machine learning, coding, automation, you name it, engineering, all of those things together are going to be so important to sort of meet that demand that develops over time. So I really agree on the education component, as well as, fostering the partnerships. And one thing I'd add too, actually, that I've been thinking about more recently is within the partnerships and collaborations, I think doing a little bit of a better job of bringing more underrepresented groups to the innovation discussions is going to be key too. Because I know there's a bunch of groups that aren't as much part of that conversation yet, and I think we could do better there, and that could definitely be a role that the government sort of directs on.
Great, thank you for those comments. I think partnership along the value chain, I think, is not unique to the sector. I think in many sectors, though, that really helps. And the government being a convener and a facilitator of such partnerships, I think, really helps bridge the gap. So we're going to open up the floor for questions from the audience. So if you want to pose a question, just go up to the mic, so that'll just make it easier for everybody to hear. So go ahead.
Thank you so much. I was interested to learn mostly about indoor agriculture, but myself, I started gardening. I have huge gardens now on my entire land, but I was wondering about urban agriculture and how you think that can combine for food security and food sustainability.
Great question. If maybe Mark, I'll pose it to you in terms of, you come from the farm, so in terms of urban agriculture, both indoor and field-based urban.
So we ended up writing a paper because that's an excellent question. We called it extreme environments. So growing things in space versus growing them in the far north versus growing them in an urban center have similar challenges. We have labor issues. Some have zero, some have low, and some have a lot. But I don't know a lot of people in this city that initially said, my goal is to become a farmer. So it's a challenge to bring that transition across. Water resources different in each location, but all the challenges are, there's not an obvious path to any of these things. So heat island effects, if you're going on top of a building here, it can get stupidly hot. In the urban cores. If you're out in the rural part, they usually have a nice breeze. We get those idyllic kind of locations. And so having a greenhouse there isn't that big. So being able to understand that even though they are different locations, the challenges in some ways are almost identical. It's just varying degrees of what each one of those ones are. And so we do work with people who are doing food desert type work. So can we bring in, so if we want to look at Plenty right now, they actually have gone into Compton, which is not the most obvious place to go, but they're doing it specifically because they're trying to alleviate one of the food deserts and higher knowledge base. But that's going to become one of the large centers of indoor agricultural systems. So we would think that Compton would be one of those. Detroit's the same thing. Urban centers of Detroit now have a lot of urban agriculture, true agriculture, greenhouses, and indoor agricultural systems, but they can tie through for all these. So the knowledge we gain on the one doesn't exclude it from using elsewhere. We also do like tropical agriculture, different still, but we still have to worry about a lot of the same parameters. So the knowledge base and getting these people together, they go, oh, I have that same issue. Like transportation of goods and services is still an issue for everybody equally across the whole thing. Finding markets. How do we get this into the grocery store? Do we want to do garden markets, or do we just share with our friends? Like all these things identical. So yes, is the short answer.
So clearly all our environments are changing and we'll have to look into it. So I'll go to the next question. If you also have your question directed to a particular panelist, please feel free to mention that as you're questioning it, or sure. You can give the question and I'll direct it. Okay. Your choice.
My name's Gavin Douglas. I'm a postdoc at McGill. And I guess maybe Mark, this would be best answered by you. But I know Proof, the policy research group on food security at U of T, they came out with a report this year, and they were just trying to narrow down like what's driving food insecurity in Canada, and they really concluded that's income that's the main covariate. And I guess so I'm wondering, we talked about a lot of different technologies and scales, and so from like a more of an economical point of view, what makes most sense in terms of really lowering the price? And so like we talked about like trying to lower electrical costs and that kind of thing, but does this make more sense at like large scale farming that you can really kind of, that's maybe small technological changes can make a big difference in the prices? Or what do you think the potential of that is?
Yes, good question. Probably Corinne will have to answer part of it also. You can do it three ways. You can do garden in your own house, which you can buy little benchtop systems that grow 4 plants to 20 some plants. They're coming out. Actually, there's a bunch of them out there. If you want to do home hydroponic system, there's a lot of systems out there. They work quite well. If you scale up, obviously the price per unit is collapsing, and we get down to those somewhat profitable in some cases, super profitable, and then there's kind of the in-between places. Our challenge is, as Corinne kind of mentioned before, is that we have electrical consumption, which ends up being heating, lighting, such. We got labor, and then we kind of have water, or kind of big three, and depending on where you are, which one dominates is that. But labor is always one of the largest concern. We're finding that the technology infrastructure costs keep coming down, but they're never going to get down to zero. So we're making it cheaper. LED lighting is still more expensive than HPS by almost double from a lighting perspective, but the electrical consumption cost is maybe just about half. So cost fluctuations on those ones. If you would have asked me that 2 years ago, I would have said that only the wealthy people would ever eat CA controlled food. We're now starting to see, as prices keep going up, that maybe everyone can afford to do it. But that's partially because just inflation's forced it upon us, and we just can't afford to transport the food. And if carbon taxes keep going up, there's probably a point where that's going to cause a shift on that also. So I guess there's a lot of research to figure out what that break point is, but I believe we're close to. We're guaranteed there is company making money. There's a lot that aren't, but as this technology shifts, it will start becoming more profitable.
Corinne, you want to add to that?
Yeah, thank you. I would say I agree with Mark. Year over year, as we go forward, the cost for efficient lighting, like LEDs, is going to continue to come down, as well as greater automation. That'll take a good chunk out of the labor associated cost, which is a big one, right? Because that's like a third of your unit economics on the product, or or your profit margin. So I think over time, those are going to start to stabilize a bit more. And I fully agree. The cost gap is starting to sort of shorten. And as consumers see the true cost, or the cost of buying something from coming into Canada, it's just not going to be as worth it compared to something that is a similar price, or once we get to that point, that's incredibly fresh, better shelf life, you name it. So I think with respect to scalability, those things are going to play massive parts into that. So I would expect that the uptake will continue to improve in the coming years, as well as we sort of need to as well. Like we need to have a better domestic supply chain that, if we've learned anything from the past few years, that you can't have the guarantees of certain things. And as Mark said, once the food sort of runs out, people start to really care about it. So I would agree with that food resiliency is basically going to be local. That's how I see it. And I think with respect to scalability, we're going to get to that hopefully in the next few years, I think.
Yeah, so I think
actually, can I jump in here for just a second?
Yes, absolutely.
So, yes, CEA food is expensive. Yes, the technology to run these farms is expensive. The energy costs are maybe expensive. But what is cheap? What is cheap food? Cheap food is calories. There's not a lot of nutritious, vitamin, full and mineral rich foods that are also high in calorie and cheap. And, I wonder, when I think about the policies of Canada, you guys have free health care. We're still grappling with how to deal with that here in the US. But I do kind of wonder what the cost benefit analysis would be in terms of, mitigating health, or heart disease and diabetes and things like that, by focusing, by maybe subsidizing healthy, nutritious, vitamin-rich foods, so that they're affordable, rather than driving everyone to these high-calorie, just crap foods that is costing a fortune in our healthcare systems all over the world, right? This is not just a U.S. issue or a Canada issue. And so I would be really curious if somebody, here's a good study for McGill for you guys to do, or any university to do up in Canada, is what is the health, or what is the cost benefit of the healthcare system versus eating nutritious food, and if we move some of the, if we subsidize healthy food, could that reduce healthcare costs in the long run?
Great thought, Nadia. I think that's a really food for thought for all of us to think that way. So in the interest of time, I'm going to make sure that we have our two people who have been very patiently waiting be able to post their questions. So go ahead.
Hi, my name is Rosemary, and I'm a master's student at the University of Guelph Controlled Environment Systems Research Facility. And actually, my research focuses on adapting a traditional native vegetable fiddleheads to indoor environments. The economics are terrible, but we're doing it to show that it can be done. But my question is actually for you, Dr. Krishnan. All the panelists identified the need for more funding and more training. Is the government working on that, and will they be giving more funding to these areas? In particular, I'm thinking about my own experience. I've been applying to an NSERC grant for a PhD in this field, and you have to pick a topic area when you're applying for an NSERC grant. And controlled environment agriculture kind of falls between the gaps. There's agricultural engineering or there's plant biology, and we're kind of somewhere in between. We're not engineers, but we're not really full-blown plant scientists either. So that's been a real challenge in getting funding as a student. So I'm just wondering what the government is doing to address that.
Great question. So one of the, I think, drivers for us to have this panel is exactly to have that conversation and stimulate the thought process of the government. I mean, I am not the person who holds, I wish I was the person who had pocket full of change that could to kind of give to the types of technologies that need to be invested in. But I think this is the conversation we want to have, and this is the message we want to have move forward in the dialogue through these policy tables, that this is a sector that needs investment. This is a sector for the future. And also, this is perhaps a sector where Canada can have leadership. We are a resource-based economy, and to change that resource-based economy to a knowledge-based economy here, we've got a great opportunity which bridges those expertise and long-standing knowledge base we have in this area. So exactly, and I would say I was quite pleased with the remarks that our ADM Nipin Vats made, that there are programs. Government is starting to think of longer haul programs, because these are not quick fixes, and sprinkling few dollars here and there is not going to help us move the bar on what we need to do. So I'm very optimistic, and I hope students like you will continue to work in this area and make your voices heard, because this is what will change. Because at the end of the day, the government will respond to what the taxpayers are demanding of it. So thank you for bringing up the question. So last question to our last audience.
Hi.
Yeah, go ahead.
So has specific research been done into the how cost effective it will be to implement these new indoor farming technologies, and situate them in Northern Territory specifically? Because on one hand, I can see that it can override some of the costs associated with food transportation, time costs, money costs, and also maybe even lower the currently high prices of produce. But also on the other hand, I think it could also be challenging to perhaps recruit people and professionals to northern areas to develop and maintain those systems. So I'm essentially wondering about the cost effectiveness of having these indoor farms in northern territories versus having them in provinces close by, and then focusing also more on the transportation, the delivery and distribution of produce.
Great question, and I'm going to give to perhaps Krin, because he's got the most experience putting these systems in various communities, and so maybe you can take 30 seconds. I know it's probably lots of things to unpack, but 30 seconds maybe to give a very quick answer.
Thank you. I'll keep it short and sweet. With respect to studies, Mark does have a paper about something in that field. If I think it's from 2 years ago, he mentioned it. That would be a good thing to dig up. From grocers' perspective, first farm, Nunavut, -50. Food there, $7, subsidized by the government. Our farm, deployed, half the price. So, that money goes back into the community. That makes more jobs. And then the other thing I would say is just, being part of the solution for food insecurity as well. So I think I haven't strictly done like a cost benefit analysis, like study report or anything like that, but we see the benefits of approaching taking this kind of approach that we've had, as well as like the CEAs themselves generally. Like an indoor farm just has just less land, less water, like can be up to 90% in both accounts there, and then the transportation costs, like making it a very short supply, or making the food as local as possible. Yeah.
Yeah, no, thank you. Thank you so much for those marks. And Mark, do you want to make one? Yeah, if you want to make one remark.
Short answer from my perspective is you need to be about 1,000 people is where most people are talking about right now. The difficulty is that if you took that approach on everything, then we should take all small communities and just force them to live in the city. I'm not a person who believes in that. So probably shouldn't do that. At least I disagree with it. But the other thing is that we've been watching. So one of my colleagues actually published a paper, would have been about almost 10 years ago, and he said CA makes no sense for anything. That was his result out of this. But he didn't take in consideration that technology is getting better. So every year it's improving. We're going to get to a point where we're not going to improve anymore. But I say that's 20 years out. And so we're following Moore's law. Everything's collapsing at a certain rate, and at some point we're going to be able to grow most things. I'm not going to expect that we grow wheat, barley, corn in the north, but we will be able to do the tomatoes and the peppers and all these other products. And then it ends up becoming, well, how much does the community value this from a social perspective as well as food? And so we can't look at it as pure economics. If we do that, then we should all live in the city and just eat gel caps. I don't want that. There's better ways to live the world than that. And so we need to include this as a social component also simultaneously.
Great final words, Mark. I think that's really kind of sums up what I've heard here. I think this has been a great session, and panelists. I want to thank all of you, Dr. Nadia Sabe from virtual, as well as our panelists here, Mark and Corinne, and all of you audience who have stayed to the end and really been engaged in the topic. What I've heard is that this is an area we need to continue to put our minds and heads together in terms of driving the unit economies below, making sure our R&D is fit for purpose, is driven by a community need, investing in education and training, and ensuring that there are program incentives for actually working in this area. Like many things, when we are starting in a new area, it's very easy to kind of blindly look at one small aspect and say, this is not cost effective, or this is too difficult, or this is not going to happen. But I think that's where a lot of us as R&D players and policymakers can ensure that we have a more longer-term vision to coordinate an ecosystem that needs investments, needs a long-term vision, and needs a convening and a facilitation aspect to make this happen. I don't think none of us can sit in urban Ottawa or anywhere else and completely understand the issues that people in the communities face, or what will they adopt, or what do they want to adopt. So I think there's a lot to be said in terms of how we make food security be the center of what we want to do. Like many things, I think food security is not something for the future. We are facing it today. I think pandemic taught us that security in many sectors is just going to be absolutely essential. We can have our borders closed down very quickly. We can have other things that hit us, but we may not be able to transport things across. So I think and food is the backbone of communities, right? So I think there's a great message in that we all want to keep sure that we keep our focus on in investing in this. So with that words, I would say that partnership and community building is going to be the key for all of us. And I hope all of you will continue to remain engaged in this aspect with many of us. And hopefully the next time we have such a panel, we'll have much more solutions than we have today. And maybe a decade from now, our children will be able to say, oh, it's like, oh, did they really think about it? This is how we do it because it's so effective. Just like we say today about this little gadget that we cannot live with. When I was growing up, I would have not imagined that this would be there for me, right? So let's hope that the same is true for many of these technologies. So thank you very much for staying to the end. Thank you.
Thanks, everybody.
Thank you, Nadia. Thank you so much. I know you can't see us, but really appreciate you joining us.